Hey, welcome back to part 2 of linear relationships, and these are linear inequalities. What? What's going on there? Have a look at what I've got here for you. I've selected a few little mathematical statements here. Now, what I want you to do is to pick out the ones that look a little bit different from what you've ever seen before. And you might take a little clue from this word up here, inequalities. Inequalities, unequal, not equal perhaps. Okay, can you see the ones that are a little bit different from what we've had before? Let's go and have a look. Hey, this dude here, what's going on there? What's that? And over here, another one of those little squiggly dudes there. I don't know what they mean. Oh, here's another one. Oh, well, I think it's what you put down if the two sides aren't exactly equal. See all of these here? They are little equations that we've been solving, and they have equal signs, so they are equations. These others are saying, well, they're not equal. Okay, this symbol is saying they're not equal, or are they? Not just equal to. Oh, we better have a look at that. Because, of course, if you think about it, if you're looking at solving this equation, you'd say 4x equals 12, and then x equals 3. That's a particular one value of the variable x which works in that equation. Most x's don't. If you were to put in x is 0, you'd have 4 times 0 plus 3, you would have 3. And that is actually less than 15. And we write it like that, actually. When x is 0, you get 3, and that's less than 15. When x is 1, put 1 in there, you get 7, and that's less than 15. So can you see, equations have one particular solution. Most x values, of course, when you put them in there, are going to give you a bigger or smaller answer than that 15. Let's try another one. Let's try x is 4, and in that equation you get 19, and that is bigger than 15. So can you see, we do need some symbols there to indicate what all the other x values that don't make the equation equal are like. Are they bigger? Are they going to give answers bigger or less than? And so let's go down and have a look at a system now that handles that. And it's called linear inequalities, and it simply means we're still looking at the same sort of function, linear. So, you know, what's the sort of function that gives a straight line graph or a linear graph? It's y equals mx plus c. No squares on x or anything like that. Just an example, y equals 3x plus 2, that sort of thing. And now we're looking at when that linear statement might be not equal to 15, if 3x plus 2 might be greater than 15, or 3x plus 2 might be less than 15. So there are our three conditions now that could occur. We've been focused mainly on where they equal. But what about all the numbers that you could put in for x that produce an answer bigger than 15, and all the numbers you can put in for x that produce an answer less than 15? Most of the x values will be in these two categories here. So we're going to introduce some symbols, and I think you're getting the hang of it already. This squiggle here means less than, so the easy way to remember it is, let's say 2 is less than 3, because 2 is on the narrow side, or 3 is on the big side, 3 is greater than 2, reading it back that way. You can read it either way. So if over here I put 3 on the fat side of the sign, 3 is fatter or greater than 2. So you can read them either way, because if 2's on the narrow side, you can say 2 is less than 3. And if you stick an equals underneath, it means you're going to include the possibility that's equal to or greater than. Let's use that symbol a bit on a number line represent x is greater than or equal to 17. So go somewhere and make a mark for 17 and greater than or equal to. So it's going to be going out this way, greater than, bigger than, that way, and if it's equal to, we shade the circle in. I actually disagree a little bit with Pearson's here. We're taking screen clippings from Pearson's again, so you follow it through in your textbook or the e-book. But they call that a closed circle. Well, technically a closed circle is anything that closes. That's not closed. But I prefer you to say it's a shaded circle or an open circle. So if you were doing x is less than, see it's on the skinny side there, x is less than 2, you're going this way, so that's correct. And it doesn't include 2, so it's unshaded, saying there's a hole in the function there, if you like, or in the set of values of the variable, you can't include 2. So it's an interesting system. And I guess we're focused always on equations, and people are thinking back up here, hey, when's it equal to? But what about all the other values of x? On what side of 15 do they lie when you put them in? What value for the function do you get? So let's go down and do some more. What about this one? Neg 3 is less than or equal to x is less than or equal to 2. So we read from that side, neg 3 is on the less than, so it's less than x, and then x is less than 2. So there's equal, so it goes from neg 3 to 2 with, notice there, shaded in circles, meaning they're both included, because there's this little equal sign under each of them here. If they're not included, from neg 3 to 2, we would say, here we haven't written that one down, neg 3 is less than x is less than 2. You still have x is greater than 2, but greater than neg 3 but less than 2. So reading it from here, neg 3 is on the skinny side, it's less than x, and x in turn is less than 2. So they're jammed between each other. X is jammed, between neg 3 and 2, and there's no equals in here under the sign, so they are unshaded, meaning neg 3 and 2 are not included in this situation, not included. Okay, are you getting the hang of it using this new symbol for the variables here? Okay, what about doing a combo? Neg 3 is less than or equal to x, but it's strictly less than 2. You can't include 2. So what does that mean? X will be jammed between neg 3, which is included because of that little equals in there, and 2, and this is not included because there's no equals under the sign there. So it's a nice little system to indicate sets of numbers on the number line that we're interested in. So this time, neg 3 is not included, so it's unshaded, but x is again travelling between neg 3, not including it. Are we going to include 2? Yes, see that little equals in there, so we're going to include 2. So it's a shaded circle, showing that point is actually included. So I want you to get familiar now with using that, because it's important in maths, with the realisation that most values of the variable don't make equations equal. Sometimes you'll get larger or smaller values from that linear expression. All right, come down, and I want you to have a go. So let's have a look at an example here. X is less than or equal to 15. It's including less than or equal to 5, sorry. So you find 5 on the number line. You shade it in because you have a that equals, and it's going to the left because x is on the skinny side of the sign. X is less than or equal to 5. What about this next one? X is greater than neg 2. First of all, find neg 2. There it is. Unshaded because there's no equals under there. Now x is on the fatter side of the sign, so it's going bigger than. X is wider than, if you like. X is wider or bigger than neg 2 on the larger side of the sign. Okay, what about this one here? neg 3 to 7. 3 to 7. So there's no equal sign. So you go to 3, it's unshaded. Then you're allowed to go up to 7, it's less than or equal to. So that's going to be shaded in there. That shaded circle, meaning it's included. Alright, so have a look, and then I want you to come down and have a go at these. So drawing a bit of a number line and then choosing left or right. Probably, I think, it would be a good idea to do all of these because you're only new to this sign. Just remembering, if x is on the fatter side of the sign, it means x is greater than 2. Greater than 2. And if x is the other way around, if x is like that, it's on the narrow side, it's less than 2. But you can read it the other way. You can say that 2 is on the fat side, so 2 is greater than x. And you can say it either way. You can read it backwards and forwards. Just remembering whatever's on the wider side of the sign is greater than the other thing. Alright, so pause it there and have a go. And I'll toggle down to the solutions as usual, and you can check them, check each one as you go to make sure you're not perpetuating some error. Right, so there are some examples there, or some number lines with those examples. So toggle back, do the next problem and so on. I'm going to go on now. Okay, so here are some examples where we are using equations that, or linear expressions, and they are inequations now, aren't they? Inequations, because there's no equal sign. Inequations, we're using this sort of sign, or even that one and that one, where we include equality there. Okay, so let's have a look at the first one. X plus 3 is greater than or equal to 12. Well, we can use the same principles by and large for solving these as solving equations. X has had 3 added to it, and it's got to be greater than or equal to 12. If we take away 3, x will be greater than or equal to 9. This generally works. There is one exception, and we're going to do this a bit later on. There's one exception to the rules for equations, I don't know whether you've seen this before, but we'll do that a bit later. There's only one exception. So what we're going to do for a start are all ones that work using the same approach as if these were equal signs. Okay, let's look at the second one. 4x take 3 is less than neg 7. What's been done to x? It's been multiplied by 4, and 3's been taken away. And you've got neg 7, or it's less than neg 7. So 4x must have been adding 3, neg 7 plus 3 is neg 4. You could put a working step in there. Okay, so we'll just do that. Adding 3 to both sides. We've got this is less than neg 7 plus 3. So 4x is less than neg 4. And then dividing by 4. Divide both sides by 4. X is less than neg 1. So it's the same sort of thing. We've just got to watch out for there's one exception coming up. And we'll have a look at that in a minute. So again, I've taken Pearson's exercises step by step, each worked example separated from the other one. So let's come down and have a look. So using the same steps now as, just a bit further down now, using the same steps as solving equations. Again, I think because this is new, you should do most of these. And just getting familiar with doing the same steps as solving equations, even though we have here that sign in there. You can see why that must be true. If x plus 6 is greater than neg 4, what was 6 before you? What was x before you added 6 to it? It must have been greater than 6 more than neg 4. You see, the idea will still work. Okay, have a go, and I'm going to show you solutions, so you can toggle back, freeze it, and toggle forward to check your answers there. So there are the answers. Check those. Notice they haven't asked us to graph the solution on the number line. Sometimes they do, but we just want the solution there. Okay, toggle back and do those. I'm going to go on now. Okay, so here we have the exception. So this is very, very important. This is the exception to using the same rules for solving inequations or inequalities as what we did for equations. Let's have a look at how it arises. Let's say that 8 is bigger than 4. If I multiply both sides by -1, I get -8 is greater than -4. Uh-oh, danger, danger. That's not right, is it? That is not right. If I multiply by -1, and let's just check this. Where is 8? 8's out here. And it certainly is bigger than 4. That's okay. When I multiply by -1, what happens? I've got -8 and -4. Now, no, this is no good. -8 is not bigger than -4 if it lies to its left on the number line. They've changed position. Bigger is more to the right on the number line. Bigger lies more that way. So that because of this timesing by -1, they've changed positions on the number line. Now -8 is to the left of -4. That is larger. So this should have read -8 is less than -4, because they've changed positions and -8 is to the left of -4, which means it is smaller than. So there's our problem. If we multiply or divide both sides in an inequality by a negative, the sign must be reversed for that reason. That implies reverse the inequality sign. Reverse the sign. Because they're going to change positions relative to each other on the number line. That's an important result there. Let's do another one. Let's say -2 is less than 1. Is it? Let's just check that. -2 is down here and 1's up there. Yep, and there's 0. All right, let's just rub that out and come over here a bit. Let's go again. So here is -2 and 1's up here. So -2, yes, is on the skinny side. Yes, it is less than 1. Why? Because smaller is to the left on the number line. Now if we multiply both sides or divide both sides by -1, this becomes 2 is less than -1 if I don't change the sign. Now is that true? Let's go, this is -1 now and 2's over here. Uh-oh, that's not true. 2 is further to the right. It is bigger than -1. That sign should have been changed on multiplication by -1. So we're going to change it. We're going to say, when I do that, the sign changes to 2 is greater than -1, because it's now changed its position on the number line relative to -1. It is now larger than -1 because it's over here. Okay, so you might try to understand that. However, you need to obey this rule. Multiplying and dividing by a negative means reverse the sign. Let's have a look at it. -4x is less than or equal to 20. X has been times by -4. We'll reverse that. We'll divide by -4. So this becomes x. The other side becomes 20 divided by -4. Let's check it. Positive over negative is -5. But we reverse the sign, because we know, even though we don't know the value of x, if you multiply both sides of an inequality by a negative, the numbers on those sides change positions on the number line. Okay, let's do this one. What's been done to x has been times by neg2. Now remember that sign belongs to the 2x. What's 9? 9 has been added, it's plus 9. So we'll reverse the step. We'll take 9 from both sides. 5 take 9 is neg 4. And we've got 2x, neg 2x still there. Let's divide by neg 2. So this would give us neg 2x divided by neg 2 is just x. Neg 4 divided by neg 2. Negative divided by negative is a positive. So that checks there. But what do we got to do? Uh-oh. We're dividing by this negative. That last step has stuffed it up for us, and we must therefore reverse the sign. Because when you multiply or divide by a negative, the two numbers on the number line change relative positions. Okay, could you notice, if you don't like this, I'll show you a little tricky-do here. If you don't like this, what you could do is add 2x to both sides. 9 take 2x plus 2x is greater than 5 plus 2x. Okay, that's disappeared. 9 is greater than or equal to 5 plus 2x. All of a sudden now we don't have that negative problem anymore. X has been times by 2, 5's been added. Let's reverse that. Let's subtract 5. 4 is greater than or equal to 2x. I'll just come down here a little bit. Now dividing by 2. It's dividing by 2 now because we've actually made it plus 2x from this step here. So 2 is greater than or equal to x, or reading it back the other way, x is less than or equal to 2. So you can put it on the left hand side if you want to. You don't have to, it's convention. You would usually do that. So that's a way around remembering the rule. In other words, change the equation so that the x term doesn't have a negative in front of it. So you might choose what you'd like to do. So let's go on and look at these where they have negatives involved in front of the x term. Alright, so I think you should again do all of these. Remember, multiplication or division by a negative implies reverse the sign. Reverse the sign. Okay, and you can see why. We've just explained why that's so. Okay, so pause it, do one, come down the bottom here and look at the solution and go back and so on, as usual. So let's have a look. There are the solutions. So toggle back, have another go. I'm going to go on. Okay, so that's all of our theory now, and we'll just get into some problems here. So question 4 and 5, and again freeze it and toggle on as before. There's the rest of 5. The answers to 4 and 5 now are there. Okay, so toggle back, have a go at them. Let's go on to the next level of understanding here. So just coming up there, 6 through 9 there. Important here, in a reserve price means you must get more than the reserve. I don't know whether you know much about auctions, but if there's a reserve price on something, it must be sold for more than the reserve. That might help you in that problem. So there's 6 through 9. So again, same process. Freeze it, have a go, and then toggle down to the solutions. So here we've got 10 and 11. And you might have a look at these. These are more challenging ones with inequalities, or these as well. Remember the usual rules about clearing fractions. Usual approach, except for the negative. Usual approach with fractions and everything, except remember the multiplication and division by a negative reverses the sign. Okay, so that's important. Okay, so I'll show you solutions up to 11 there. Think we can get them all on? Yes, so up to 11. So toggle back and finish the problems off and have a go. Okay, the last ones now. Well, there's a few more. 12 through 14. Can you reason what is happening here? So again, maybe in this problem solving, it might be a good idea to underline the key facts. The key facts or given information. And it's important that you use all the given information. That's important. Okay, so have a go. And again, I'll take you down to the solutions now. I'll just come back a bit. Just down here. Okay, 12, 13 and 14. So toggle back and have a go. And then finally the open-ended questions. And again, depending on the numbers you choose, so your answers will all look different from each other, and we'll go down to the solutions there. There are some typical answers. Okay, well, isn't it building up? It's interesting to see how we are expanding our knowledge, looking at the language of mathematics developing to cover all possible scenarios with our greater than or equals to. So that's all good. We're going to move on with the unit called linear relationships. With the rest of chapter 4 will be drawing graphs and slopes and of lines and all sorts of things like that. So we'll be coming back to look at that a bit later on. So I hope to catch you in those presentations, but for now it's cheers from me.